thanks for coming along to our panel on 5G. We've titled this 5G is no myth, and we've got a subhead which is Rethink Everything You Know. Because 5G, if things go according to plan, should have quite a significant effect on society. It has potential to be a big step change in our communications business. And as a result of this, it's going to mean quite a lot for the IoT sector. So for the next 30 minutes or so, we're going to look at 5G, what 5G is and what 5G should be, and what it means for IoT. So let me quickly introduce myself. My name's Guy Daniels. I'm Director of Content and co-founder at TelecomTV, and we've been producing video-based material for about 15 years for the telecoms industry, and covering it for an alarming 25 years now, I'm fortunate to say. Now, I'm joined by three colleagues on the stools to my right, and if I can start from my immediate right here, we have Dr. Mike Short. Dr. Mike Short, OBE, is Vice President at Telefonica Europe, and Mike's enjoyed a long and distinguished career in telecoms. He was Director of Cellnet, if anyone remembers Cellnet, back in 1989. He was also a Chairman of the GSMA in 1995. Served on its executive board for 5 years, chaired the UK Mobile Data Association for a good number of years too. He sits on numerous government boards and committees and is a fellow of the IET, and he's a visiting professor at not one but 4 universities in the UK. Next to Mike, on his right, is Matt Hatton. Matt is the CEO and co-founder of Machina Research, and Matt has 15 years experience in telecoms research. And prior to establishing Machina, which focuses on the M2M, IoT and big data sectors, Matt was program manager at Yankee Group, and before that he was at Analysys Mason. So welcome, Matt. And next to Matt, on his right, is Dr. Payam Banerjee from the University of Surrey. And Payam is a reader in machine intelligence at the Department of Electronic Engineering. He's a member of the Institute of Communication Systems at the University of Surrey, which also has the 5G Innovation Centre. And if anyone wants to know more about 5G, the 5G Innovation Centre is the place. It's a remarkable achievement of what they're doing there. He's a senior member of the IEEE and a fellow of the Higher Education Academy, and he's currently a coordinator of the EU CityPulse project on smart cities, and is a technical lead of the NHS Innovate UK IoT testbed for healthcare project. So smart cities, we're in good hands. Before we start, I'd like some audience participation, if you don't mind, just to establish kind of a baseline. Can you just show me how many of you work in telecoms? How you got direct work in telecoms? Oh, great. How many on the vendor side of telecoms? Oh, okay, a couple there. And how many of you have no connection with the traditional telco industry? Well, that's quite a lot. It's a good balance then. Great. Who amongst you thinks they know what 5G is and what 5G represents?
Come on, Mike.
This is going to be a tricky. Oh, there's one hand there. There's one hand. Right, we have an expert on this on the middle row, on the left-hand side. How many of you think that 5G is more marketing hype than anything else and a bit far-fetched? Any of you think it's a bit overblown? Oh, jolly good. We have a yin and yang. Down to business then. I think we've established, we've got a cross-section in the audience here, not all traditional telecoms business people, and anxious to know more about 5G. Mike, can I start with you? 5G isn't here yet. 5G means a lot of things. We've got an air interface, we've got a whole network architecture. Can you summarise for us, what 5G represents? What is it?
I think we should start with simple things like customer needs, but to me that could therefore be capacity or capability or even better access to content, particularly video content. But I think we could also can imagine this as being a gigabyte era of around 2020 onwards, but overlaying some of the existing technologies that exist, including cellular and Wi-Fi and some other technologies.
And Matt, we were just chatting outside there. There are a lot of different, not definitions of 5G, but there's a lot of thoughts of where 5G could go. What's your take on what 5G represents?
It's not a simple question, really. Because you get asked the question regularly. Okay, what are the likely implications of 5G? What's the impact likely to be? And the answer is generally, if you can tell me what 5G is going to be, I will tell you. Now, we can work through some. So we have a general framework, an idea of some of the capabilities that are in there. It's to do with using licensed and unlicensed spectrum. It's to do with massive MIMO. It's to do with do we still use the term het nets? It's kind of heterogeneous networks, right? But that kind of approach, and obviously a lot more bandwidth and using higher frequency spectrum. It's a whole host of different things, really, rather than just one thing. So it's a little bit difficult to put your finger on it.
Pam, from the sort of academic perspective, on what you're doing in the university, a lot of research, a lot of early research work. What is 5G for you at the University of Surrey?
I think if you look at like the previous generations, 2G, 3G, 4G, always is the network becomes faster, your delays become less and less. Of course, 5G, as Mike said, is about capacity, building capacity, a gigabit, decreasing the latency. I think the initial target is 1 millisecond end-to-end delay. But it's not just about that. It's about ecosystem, building an ecosystem of applications around it. It's not just having faster networks, having less end-to-end delay. It's being able to run different types of applications. Give you an example. My colleagues, they do at 5G Center research with BBC. BBC iPlayer has given us some data of the access, the content you access on iPlayer, all anonymized. We have 3 million of this access data, and my colleagues have processed this and have created a model. Basically, our model can actually predict what you're going to watch next. And by accessing the mobile communication data, also we can predict your mobility. Means if I know where you are and what you're going to watch, I can move that content closer to where you are. Then, in fact, it's not the network doesn't become faster in terms of physical connection, but your experience could be 100 times faster because the content is very close to where you are. Then it's about creating an ecosystem of systems which delivers this.
So Mike, this is more than the usual step change we've seen from 2G to 3G to 4G. There's far more to the potential of 5G than just that.
Yeah, I think also some of the European Union initiatives about looking at verticals are very important, because if we can do user-driven standards, we can make sure that when it launches, it's fit for purpose. So already there's good work across from the energy industry to say what would their requirements be, transport, what would their requirements be, and other sectors perhaps such as health. So one of the good things about 5G IC is it's already looking across into those sectors to inform how standards could help some of those sectors going forward.
Because previously we haven't involved the vertical markets at the early stage, have we? But we're not even at standards level yet. We haven't created the standards, and yet we're already talking about why don't we think what these big vertical industries actually need from us?
That's the aim. I think in reality, I can go back to 1G, never mind 2G or 3G or 4G, but in terms of those, they were largely standardized by the telecoms community. But I think 5G's got much more user behavior to build on, and some sectors standing forward to say, you're not doing this with 4G, or you're not doing that with 4G. So can you do more with security maybe, or more with resilience? So those sort of factors are being built in, and internationally, not just in the UK, there are mechanisms to do that.
It's 3GPP, are those vertical sector organisations getting involved with 3GPP then? Sorry, I'm jumping in and asking a question myself, but I think it's an interesting conversation.
Yes, so during Mobile World Congress, European Commissioner Oettinger had an initiative which was very much about how to get those verticals involved with 3GPP. But within ETSI, which hosts 3GPP, historically they've had an Intelligent Transportations Group, or ITS group. So that's a natural plug-in from a transport angle. Yeah. Equally, Senelec have done some work in the areas of energy and smart home. That's a natural plug-in from the energy side. But there are other sectors that are being plugged in through the ETSI mechanism towards 3GPP, yes.
I think at this stage, I'm just going to flick a slide over. It might be difficult for you to see this, but this is a 3GPP slide, since we're talking about 3GPP, and my colleagues here can't really see this because it's behind their heads. Let me just explain through. There's a couple of bar charts going across, and there's a big blue line at the top, which represents the work the ITU is doing on 5G, and that's really, at the top here, it's focused on this air interface, this ability to get a lot of data at a low latency, the air interface, the wireless aspect of it. And the key thing is looking right to the right, because this isn't going to get ratified really until 2020, or in time for 2020 rather. So there's a lot of work. We're about 18 months away from getting bids in, candidate submissions to see what that technology is going to be. So we are at an early stage. Looking down at the green line, you probably can't make out any of the writing there, but this is all the 3GPP timeline. So not only are they developing the LTE specification and going through release 13 is just frozen, you've got 14 and 15. LTE is progressing at the same time as the 5G work. So it's a very complex picture before we actually get to 5G, and there's probably people missing from that. I mean, there's no sign of the IEEE on there yet. Where's Wi-Fi? Will Wi-Fi play into the 5G picture? No information at the moment, but we never know. We've got some time to go. But it's a complex picture. But there are some very hard stops in that timeline. I'm just wondering, are we confident that we are going to get to those dates, those key dates, and achieve what we set out to? Mike, what do you think?
Confidence is a difficult one to judge, but I think there are some drivers that give us confidence. The drivers include demand, so just take some countries that have burgeoning demand for more capacity. So that will be a key driver, particularly for some big countries, particularly North America, particularly Northeast Asia. Secondly, there are drivers to do with major events. So there's clear evidence that there's interest in Korea and in Japan to do with major sporting events coming up, where they identify 2017 and 2020, probably as pre-standard 5G, but probably early demonstrators as well. We also see the European Commission saying, historically we've had leadership in mobile with GSM and the coordination that took place on a European basis. That became a global standard. But the reality is they would also like to see demonstrators in Europe. So demonstrators are another set of drivers as well. I think Oettinger referred to the European Football Championship, which in 2020 is due to take place in many cities. So maybe there'll be many demonstration cities in 2020. But there's a lot to be done. However, we shouldn't forget that in the meantime, a lot can still be delivered with 2G, 3G, 4G and Wi-Fi. So it's not as if those are standing still either. I mean, O2 in the UK, we're investing £600 million, of which the vast majority is going into more capacity and coverage for 4G.
Matt, Payam mentioned earlier about latency, the one millisecond. There's a big talk about we need latency down to 1 millisecond, which is phenomenally fast compared to what we've got at the moment, and that translates to very short distances. So Matt, I'm just wondering, from the industrial side, the M2M side, the verticals. It seems that automotive is probably, the main driver behind that latency need.
Yes, I mean you can kind of, just to step back a bit. There's kind of two drivers for 5G. It's about capacity and it's about latency. When you boil it down to the applications you're talking about, there are applications that will benefit from higher bandwidth, and there are applications that will benefit from latency. The bandwidth ones are relatively easy to work out. It's connected car, it's digital signage, it's CCTV, it's these kinds of high bandwidth applications. When it comes onto the latency side, well, to a certain extent we don't know, because we've never had networks that have been able to deliver those kind of capabilities, certainly wireless networks have been able to deliver those capabilities until now. But you can hypothesize about applications, things to do with maybe remote surgery, certainly healthcare related applications, autonomous driving, platooning of vehicles, because you need the reactivity there, things to do with transportation systems, anything where you need to be able to react very quickly. So there are some applications that naturally jump out, mostly around probably very complex industrial processes and around some of the healthcare applications probably.
So Pam, you've been looking at, you look currently at healthcare. How does this all fit with healthcare? What can 5G offer to healthcare?
I think, as Matt says, in healthcare, the latency and reliability becomes very important, because if you're going to now monitor a patient and you're going to monitor them, let's say, around the clock, the system you're going to use is not just delivering data. You have to trust that system. For example, if you're developing something for really a patient can die if you get the data wrong or you lose your connectivity. There must be a system you can trust. Then traditionally, if we had less voice communication, internet communication, if I walk somewhere, I lose my connectivity for 5 minutes, it's not that crucial. But here, the reliability becomes important, which part of that needs to be like the low latency.
So let's focus back in on IoT. It's the Smart IoT London event after all. To what extent does IoT shape the development of 5G, and conversely, what's 5G going to do for IoT? Mike, do you want to start off with this relationship between 5G and IoT?
Let's work it from one direction first. Hang on. So, what does 5G bring to IoT? Well, I mean, I mentioned the different applications that might be able to take advantage of a more sophisticated, just simply faster air interface and that low latency. There's a bunch of applications which would benefit that. The way in which IoT influences the development of 5G, well, it's top priority for just about every carrier, every vendor in the world at the moment. So anybody who's developing standards, the people who are developing the standards are people who are part of the telecoms industry, and if the telecoms industry is focused heavily on IoT, which it is, then inevitably it has an impact. But I think we've done some analysis. We've looked at the numbers, and the main driver, as far as air interface is concerned, for adoption of 5G is still going to be handsets and tablets and so on, because that's where the lion's share of the demand is, and the lion's share of the demand for high bandwidth services.
Pen.
What Matt says is perfectly summarizes how 5G fits to IoT. But I use two examples. If you've recently seen the BBC's Human Brain program, they did an experiment. They took sprinters and they asked them to start their running, basically trigger their run by light and by sound. Basically think if they see the light and they start running because the light travels faster, they should start faster, and sound travels slower. And they did the experiment. In average, actually, sprinters started their run by light 40 milliseconds later than people were triggered by sound. The simple justification for that is human brain takes time to process visual information. The same thing for the networks. Even we increase the capacity, we make our networks faster, still once we have lots of data, processing that data will again become crucial in your network. And what 5G brings to the picture is the intelligence you add to the base stations. Now my base stations don't only relay my data, can do part of the process. Another thing again from biology is human eye. Human eye has around 120 million sensors. As I'm looking now, 30-40% of my cognitive brain is just dedicated to process visual information. And if all this 120 million fire back to my brain will explode, cannot process that information. And human eye uses a mechanism called selective attention. As soon as I just looked at this gentleman, the entire audience, they blend in the picture. I look at the color of your shirt, I don't see the other details. And then the sensors switch them on and off. Again, what we can do with 5G, if you have massive scale, larger scale of connected devices, which like Cisco predicts 50 billion by 2020, then we need sort of intelligent ways of enabling their communication, which 5G probably is a good way to deliver that.
So Mike, this implies a whole new architecture that's going to get rolled out using some of the technologies we're already in use now. The NFV, SDN, looking at mobile edge computing, bringing intelligence down to the edge. It's not all about wireless, is it? This is a fundamental rethink of our networks.
No, well, we're already seeing combinations of networks of different natures, such as cellular and Wi-Fi, and why don't we have cellular and broadcast, for example? I think the Internet of Things is about handling the volume of things out there accurately, but needing to think about their identity, so that when you get the data back, you can actually group the identity and take some data extrapolation from that, some visualization from that. It's also quite important to think about some of the other things in the ecosystem beyond the network as well, such as the billing system. How do you do the billing in this arena? How do you do some of the security in this arena? How do you do some of the customer care in this arena? It's not just going to be done by the mobile network operator, it's a bigger ecosystem for many players. So therefore, the idea that the mobile network operator does everything, that's been nonsense for a few years, but actually there are more opportunities in this area emerging, particularly if we think about moving from a verbal to a visual world, where it's much more to do with visual communications as well as better data analytics.
We're also hearing that 5G is going to enable tactile interfaces as well. So you've got the audio, you've got the visual, and you've got some tactile feedback. So, Matt, I guess this opens up the market to a lot of innovation, a lot of ideas, and new businesses and new business models.
It does, and I mean, if IoT is about anything, it's about new business models, right? We've gone from a world, thinking about things from the telco space, we've gone from a world where effectively you've got 4 or 5 different products that are charged for in 2 or 3 different ways each, maybe, to a world where you've got a huge diversity of different applications that all work in different ways, they'll be charged for in different ways, that all require different ways of management. And so implicit within being able to manage the IoT, to bill for it, to support it generally, you'll need a lot more capabilities. You'll need in terms of rating, charging, all of these back-end capabilities within the network. There's obviously an implicit requirement for more sophistication there as well.
But I think whether you go tactile internet or not, I think the economies of scale in this area are vital, which need to be as global as possible to keep the unit cost down. Whether it's the unit cost of the device, or maybe the modem, or maybe the service, keeping the unit cost down will rely on standards, which is why good work needs to be done in the next 3 years on that.
If we look at the connectivity market for IoT at the moment, there's choices. There's cellular. Cellular doesn't get a massive chunk of that. There's low power wireless access networks out there. There are alternative ways to connect IoT devices. What will the appearance of 5G or the emergence of 5G do to these, I won't say alternative, because that denigrates them a bit, but these other connectivity methods?
It's all part and part. Well, there will always be a diversity of different access technologies to address different requirements. So you mentioned the low power wide area networks. Unapologetically low bandwidth, because the principle is that there's a whole host of IoT devices out there that really don't need an awful lot of bandwidth, and you can do that better through some of these networks than you can through cellular. That makes absolute sense. But I think one of but that's not. But having those networks isn't a conflicting thing with 5G. We're expecting mobile operators to deploy these networks when we get the narrowband IoT standard coming through later on this year. We expect deployments of these networks. But one of the principles associated with 5G, as we see it, is that it can allow for all of these diverse networks and use all of these diverse networks to support connectivity in whatever form it might take. And I mentioned licensed versus unlicensed spectrum. It can use both. It can use high bandwidth services, technologies. It can use low bandwidth technologies. One of the underlying principles of the architecture, I think, is that it can support all of those different technologies and in a common way and in a joined up way.
I have to be very careful saying this, but I'm an academic, I can get away with it. I think traditionally, telecommunication industry has been very closed. So everything is about IPRs, patents, standards, and then once you have the standards, everyone has agreed, you release your new generation. But if you look at how web and internet has developed, I think communication industry moving towards that way. There is a body like IETF, which standardizes some of the network level standards, and W3C looks at the interface layer like HTML. If you look at the early years of the web, W3C had some control on standards for HTML, but they don't really control it. A big company comes like, let's say Google, says I'm using JSON. They don't care whether W3C standards is it or not. They have products and they have a large community behind it, they use it. And my feeling is in IoT, how it's going to relate to 5G, we won't have really strict standards. Depends who can have a winner product and who can have bigger market for that, and they will start evolving. Obviously, then if you want to be a successful 5G, you need to go support them. They don't need to comply to what you do. We'll have to be very careful.
So it gets to be more of a loose set of proprietary standards and actual standards all lumped under this umbrella of 5G. I'm not saying you're wrong by any stretch of the imagination, although I sort of wish it were otherwise.
It's a mix of hope or dream I have, and I think what I think is we are moving more openness, and then you will have part of open networks, open standards, open communities, and then you have proprietary telecommunication service providers.
How do we avoid the need for IoT device manufacturers to have to put a ton of different modems in there, a ton of different chips, pay a ton of different IPR to support all this myriad of solutions? Is there a solution to that?
Well, I think there are two things that need to happen. First of all, we need to maximize the common spectrum bands that are being used, because otherwise that will cause salami slicing amongst all the manufacturers. Secondly, we need maximum global standards possible to be cost effective. I think the open systems approach may help, but I think on the network piece less so than on the point for the device vendors you're raising there.
But I think we're at the point now where a lot of different technologies are surfacing, and there will be a bit of a shakeout. Right? Over the next 5 years, we'll probably see it shaking out. We do a set of predictions every year. We did ours in January. We said effectively sometime this year, one of the low-power wide area technologies that are in use will become effectively commercially redundant. I'm not saying which one, and we didn't predict which one, but these things will naturally shake out over the course of a few years. Based on a few things, based on consolidation, based on technological developments which will allow you to make use of multiple technologies. And there will almost inevitably be a set of technologies which are more appropriate for your application depending on what it is and what it does. So would you bake Wi-Fi into a connected car? Well, internally, yes. In terms of external connectivity, probably not. Right?
Let's fast forward, shall we? Because we're looking at the chart up there, and we're looking at 5G 2020 plus, and it's going to be 5 years before we see significant 5G and get into the millimeter wave communications, the real hardcore 5G, if you like. So we look 10 years on, it's now 2026, we're here at Excel, it takes less than 2 hours to get to Heathrow, hopefully. What does a smart 5G powered and IoT enabled London look like in 10 years' time? Why don't we start with our smart city expert, Payam? Give him the hard question.
Go on.
When I started my smart city projects, I went and looked back how people were thinking about smart cities in 50s, 70s, and all were wrong. In 50s, people thought our cities will look like spaceships. In around 70s, 80s, people thought everything will be like I showed earlier. I gave a talk and I showed a picture of Los Angeles. LA Times had written an article with electric cars, 400-story buildings, everything is automated. And then I showed a picture of Los Angeles in 2013, which in average people spent 4 hours of time in traffic jams. What I hope 5G in 10 years or a smart London will be, probably will be obviously connectivity, better user experience, but our infrastructure, our city infrastructure, from the services, from the public transport, from our energy grid, our homes, everything can connect to a network, and they can interact with each other. And then the decision makers, the policy makers, they have a holistic view of all this data. Again, traditionally we have been collecting this data by different means, but often this data hasn't been connected or hasn't been real time. What I think is a smart London will provide, being able to collect data near real time, not really real time, and being able to integrate different sources of information together.
I would agree with that. I think, in answer to your question, possibly surprisingly little. The time frames about making fundamental changes to how we live our lives is extensive. There are a lot of different applications. Okay, connecting street lighting so you can more efficiently manage street lighting, connecting traffic systems so that you can get that to work in a more effective manner, connecting the rubbish bins so that you can make sure that's all done in the most efficient, or collection of rubbish is done in the most efficient way possible. All great applications, and they'll all work very well. And it's. The thinking is at the moment really it's kind of more of the same in that way of working, but it's taking all of that data and combining it, making it available to other people to effectively build applications that drag in this data. So I think the next 5 years might be about connecting all these things, and then the following 5 years is about, well, how do we actually get all the value out of having that connectivity out there in the field, and indeed finding ways in which there's a better way of doing it than having remote sensors, right? You take a good example of you have sensors in roads to be able to tell you how much traffic is going across those roads. And they're very expensive to put in, and they go wrong regularly, and you have to dig up the road and repair them. But you can do the same thing with a camera. You stick a little camera in, and you can do it. So I think actually one of the things that will come through in the next 10 years is alternative ways of doing it, which are cheaper and easier. Crowdsourced information to rather than for driving and finding parking spaces, for instance, rather than a complex network of sensors, which does the same job, but it's much more heavy lifting. So again, in some cases we'll find that the complex technological solution is the right one, and in others we'll find that it wasn't, and there's a simpler way of doing things.
Thanks, Matt. Mike, do you want to have a stab?
I prefer to break it down into the sectors that the city serves. So assuming the City of London is our leading sector, financial services, I think we'll see a lot more use of video communications between the financial sector and the nations and people it serves. So video, to me, is very important for the financial services sector. I think it's also very important for the creative industries, where London is strong. And I think the idea that all the creative industries need to be filmed, edited, and distributed from London is nonsense. So I think actually London will see a reshaping of the creative industries, because the power of video will be so much more different, and you'll be able to do so much more in the field than in a central London location, including editing on the fly. I also would suggest that energy infrastructure will become absolutely critical to this. I would also suggest the adoption of ICT in its broadest sense in transport will be much more radical. God forbid how long it took us to get Wi-Fi on the London Underground, but actually, we need to step over that big time within 10 years. But I think also the power of data will mean that people can create new jobs and new opportunities, not necessarily based alone in London, but outside London. So I think we'll get a lot more remote working into London rather than in the congested London that is today. And I think data analytics will play a big part for all these sectors, not just IoT, not just 5G, but particularly the cloud computing and data analytics together.
Thanks, Mike. Pam.
I'm an academic. I make a living of making things more complex. But one thing we have to be really careful is, often when we do these things, especially in a smart city, we always show things become more luxury. Like I work on use cases, for example, smart bins and then report things. But one thing we have to be careful, also we need to find right solutions which helps also deprived areas. Revitalizing areas which are losing their infrastructure is not just going to finance, say downtown somewhere like in city area, and then helping them to have better services. I live in West London. And in the borough I live, our council decided not to put these electronic boards on bus stops. I have an app which shows me when the bus arrives. And for a minute, let's assume everyone has a smartphone, everyone can use it. One morning, I opened my app, and the app said, I give you the first one, and for the rest you have to pay. And that's something we have to be really, really careful not to create again another gap. A good technology for Smart London in 10 years will be something which becomes widely available to everyone, regardless of their access to technologies, their knowledge about the technology, and in everywhere.
Right. All done?
Actually, I wanted to pick up on the energy thing that Mike mentioned. This is a very interesting area. So effectively, we're moving from an environment where energy generation is done centrally and consumption is done in a distributed manner. And now, energy consumption will still be distributed, but you would also have distributed energy production in the form of microgeneration with solar arrays and wind and so on. Which means you have to have a different way of managing consumption and production of power. And a lot more people are going to have batteries, either home batteries or batteries in their electric vehicles, which will effectively just be a power cell within the home on wheels. and managing those interrelationships between, okay, well, I'll allow you to draw down the power out of my electric vehicle at times of peak usage, and you pay me back for putting the energy back onto the grid. It becomes a very complicated thing. And the ability to do that with very low latency and to actually be able to manage that, it's kind of like the IoT in microcosm, because you've got lots and lots of different users all selling their data or their energy to each other and with various different trading arrangements. And I think we're just starting to explore that a little bit now. And then once everybody's got smart meters in their homes, everybody's got electric vehicles in their drives, everybody's got solar arrays on their house, it's going to become a significant area for well, it's got management headache written all over it, and it's going to require an awful lot of thinking about.
It is approaching 10 past. I'm afraid we are out of time. I'd like to thank everyone for listening, and to especially thank my three colleagues here for a very, very interesting chat. 5G is no myth. Hopefully, we've proved 5G is no myth, and there's a lot more work to be done, though, before we all reconvene in 2020 and see the fruits of our labour. But for now, thank you all very much indeed.